It's your friendly math tutor, Miss C here, and today we are talking five-number summary. So, the five-number summary is another way to represent statistics in a slightly different way than measures of central tendency, and that would include mean, median, mode, and range. And one of the strengths of the five-number summary is if you have outliers, the five-number summary is not necessarily impacted by the outliers. So a lot of statisticians like seeing this summary as a result. So let's talk about what we are really doing when we're finding the five-number summary. We're essentially dividing our data into quarters. So this is basically 4 quarters make a dollar. There's 4 quarters in a basketball game, in a football game, other games as well. Basically, you find your value at the 25th percentile, the 50th percentile, and the 75th percentile. And what that does is it gives you different snapshots of your data over time. So the good news is we approach this in the same way that we would approach finding the measures of central tendency. So the first thing we always want to do is look at our data and reorder it from smallest value to highest value. I've already done that for us. And then we are going to do a couple of things that are different. We are going to start by finding our minimum and maximum. So in this case, our minimum is 4, and our maximum is 20. All right. Now we're going to find our median, and some people call this, it's the 50th percentile. It's the middle of the data. So this is where 50% of our data falls above the median and 50% of our data falls below. So the way that we do that, there's a couple of different ways, but one of the ways is you can count in the same number on each side. So I went in 1, 2 on each side, 3 on each side, 4 on each side, right? And now our middlemost number is 12, and that is our median. Okay. So this is our median. All right, so we know that 50% of our data falls below the number 12 and 50% of our data falls above the number 12. Okay, we can see that. So quartile 1 pertains to the middle of this data set because now we're going to try to find the 25th percentile, also known as quartile 1. So I know that if I count 2 on each side, the median is going to be right here. So you could have done the same highlighting trick that I did here, but since it's only 4 values, it's easy to find the middle. So the middle is actually going to be the average or the midpoint of these two numbers. So I can do that in my head. I know that the middle of 5 and 9 is 7. For data sets where that's not as clear, you can add these numbers together and divide them by 2. It's the same thing in every data set. So I know that 25% of this data set lies below the number 7 and 75% lies above the number 7. Okay, that's what this value, this quartile 1 or the lower quartile is telling us. And then I'm going to do the same thing here. I still have the same number of values here, so I know my middle two numbers I need to calculate to find the quartile 3 or upper quartile value, and it's going to be in the middle here, right? So I could add these two together and divide by 2, or I know the middle of 15 and 17 is 16. All right, what that tells me is 25% of my values in this data set lie above the number 16, and 75% of the values in this data set lie below the number of 16, with the caveat that there is no value smaller than 4 and there's no value larger than 20. All right, there is one other value associated with the five-number summary that is not part of the five-number summary, and that is called the interquartile range, and we abbreviate that as the IQR. And what it looks at is the difference between quartile 3 and quartile 1. So we're trying to basically figure out the difference between the middle two values. So in this case, our IQR would be 16 minus 7, and that gives me an IQR of 9. So what is really useful about this is it tells you about the middlemost part of the data. So the middlemost 50% of the data, there's only a range of 9 values here. when you have a lot of values in a data set, that's pretty helpful to know how much difference is within the middle values. So again, this is just showing us some different values. It helps us see the shape of the graph or of the curve, and if our curve is skewed. But those are terms for a different video. So let's actually see how this would work with a real world example. And because sports has a plethora of data, I've chosen an example from football. So let's have a look at that. From the regular 24-25 season for the Philadelphia Eagles. This is courtesy of ESPN's website. And we're looking specifically at total touchdowns by players. So anybody who did not score a touchdown is not included in this data set. I also omitted their place kicker because he doesn't score touchdowns, he scores field goals. So, what I'm going to notice, first of all, is that my data is written in descending order from biggest to smallest. And when we do a 5-number summary, we need to have the data written in the opposite direction. We need to go from smallest to biggest. So, I'm going to start as a first step in rewriting this. So, I've got 7 ones. 3, 4, 5, 6, 7. Okay, and then I'm just going to quickly redo this. It's super nice when the data is written in order because otherwise, that can be the hardest part of this whole thing is reordering the data. It seems to take forever. All right, I'm going to note our minimum and maximum. Our minimum number of touchdowns scored was 1. Our maximum number was 15. So what this means is at least one player scored 1 touchdown and at least one player scored 15 touchdowns during the season. All right, now we jump to our median. Remember, this is the middlemost value. It separates the lower 50% of our data from the upper 50%. And I believe we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 values. So I know that I need to count in 6 on each side. And I'm going to actually have to potentially take the average or the mean of the values. Since it's an even number, my median isn't going to fall nicely like it did in the last example. So I'm going to count in 1, 2, 3, 4, 5, 6. So this is one of my middlemost numbers. And then I just like to double check 1, 2, 3, 4, 5, 6. This is my other middlemost number. So what that means is these two numbers get averaged together to find the median. Luckily, they're the exact same numbers, so the middle of 1 and 1 is just 1. Okay, so our median technically is the middle of these two numbers, so neither of these numbers counts as the median, which means they do get counted when I'm trying to find the values for quartile 1 and quartile 3. Also, just a quick side note, the median sometimes is called quartile 2. Okay, so you might hear that. They're interchangeable terms, so median and quartile 2. All right, so let's just really quickly talk about the median means in context. What this means is 50% of the players scored 1 touchdown or less, except not less because our minimum's 1. So scored at 1 touchdown. And 50% of the players on this team scored more than 1 touchdown, but no more than our maximum number of touchdowns, which is 15. All right. So that makes our interquartile range pretty easy to calculate because everything below the median is 1. So we know that our interquartile range is going to be 1. But I would be picking my middle 2 numbers here again. So there's 1, 2 on this side, 1, 2 on this side, because not all data sets look like this. So my quartile 1 value is between these two number ones, which happens to be 1. So interesting data set in that because our median is the same value as our minimum, we're ending up with values that are the same for our first 3 values in our 5-number summary. Now things get a little more interesting on the other side. We need to find our middlemost values here, which are 7 and 8. So we counted 1, 2 on this side, 1, 2 on this side. So our quartile 3 value is the median or the mean, it's the same, of both of these values, and that is 7.5. Okay, so you could reason that out that the middle of these two numbers is 7.5, or you could add them together and divide by 2. That works every single time when you have two values that are adjacent for your middle point. So what this value means is that 75% of the players scored 7.5 or less touchdowns, and but at least one touchdown, right? Because that's our minimum. And 25% of the players who scored touchdowns scored more than 7.5 touchdowns, but no more than 15 touchdowns. All right, let's find our IQR, our interquartile range. So I am basically taking my quartile 3 value and deducting my quartile 1 value. So it's 7.5 minus 1. So my IQR is 6.5. Okay, so what that means is the difference between the 25th percentile and the 75th percentile was 6.5 touchdowns. Okay, so this is an interesting data set to use a 5-number summary on. I do think it's interesting to look at measures of central tendency here. If we were to look at the mode, my mode is 1, right? The most common number is 1. We already know the median, and I don't actually think the mean would be super useful for this touchdown, given that we have half of our values um, are 1. Actually, more than half of our values are the number 1. So it would be skewed very much toward 1. The range could be an interesting number to look at. So there is a 14 touchdown difference between the highest touchdown score and the lowest touchdown score. It's a pretty big range considering the minimum and maximum. So that is how you use the 5-number summary and what it means. I'll make another video that shows this with different values, but also teaches you how to do a box plot, because that's where these values can be visualized into a graph. All right, thank you for joining me. If you found this video helpful in terms of finding the 5-number summary, please like it so other people see it. And don't forget to subscribe so you don't miss a video. Till next time, remember, you've got this.